Our next speaker is Mike Jones from the University of California Cooperative Extension. He's a forest advisor for Mendocino, Lake, and Sonoma counties. Mike specializes in forest health, disturbance ecology, and integrated pest management. Michael conducts an extensive program focused on helping forest landowners and managers steward their conifer forests and oak woodlands. Mike's family goes back 8 generations in California, and his current favorite tree is the valley oak. Welcome, Mike.
Well, thank you for the introduction. Good afternoon. We're going to talk about Mediterranean oak borer. Who's heard of that? Oh, come on, guys. All right. So, Mediterranean oak borer, newly detected invasive ambrosia beetle. I'll talk a little bit more about it. We're going to spend most of this time on that insect. I don't know kind of the demographics, but if you're consultants or you work in the space where we found the insect and where it's likely going to go, hopefully you're aware, or come talk to me some more if you have questions. Where's my advance? There we go. The big green arrow that says forward. All right, so in entomology, we like acronyms and to make things short because we're lazy, so we call Mediterranean oak borer MOB. That's the insect itself right there. That's the tip of a mechanical pencil. It's an ambrosia beetle. You guys should be wowed by this. Ambrosia beetles are pretty spectacular little insects. Instead of having internal gut digestion, they farm a symbiotic ambrosia fungi inside the galleries, which is the black. So the lower picture are galleries or feeding tunnels from the beetle. And the black is their symbiotic fungi or ambrosia fungi that they farm and then feed on. So they let the external digestion happen, and then they eat the juices and the kind of digested material. I don't know why you guys aren't as oohing and ahhing. It's amazing. Thank you. God. Plant nerds, give me a break. All right. The trick with this is that they also, because they have these sporangia, these like little pockets that can carry their ambrosia fungi with, they pick up hitchhikers, and sometimes those hitchhikers can be very virulent or pathogenic. So the particular symbiotic fungi for mob, so mob is Boris in the ambrosia beetle family, is Rafflesia. And a lot of Rafflesias are pretty virulent. Think of red bay ambrosia, red bay wilt, but also carries fusariums, and we have local fusariums that can be pretty significant pests as well. So that's kind of the trick is it's not only the insect itself feeding, but it's the pathogens, the fungi that they can transport that become serious issues as well. In California, the known hosts are the white section of the white oaks, right? In particular, valley oak, that's its favorite host. We've also found it in blue and Oregon white oak. And then in a couple instances in heavily stressed California black oaks, we found them in branches, but very limited feeding and infestation. So very much, and in their native range, the white oaks as well, which is the Mediterranean region. We're really original with names as well. So the current range in California, and this is the first detection in North America was here several years ago in 2019. Initial detection was in northern Napa Valley, Napa County. Based on the signs and symptoms, once we started looking for it, we figured it's been here, which is pretty typical invasive insects for at least 5, 10, 15, probably even longer than that years. And so the area that I'm talking about is highlighted in the black kind of boundary. By 2021, we really started to recognize the extent of the infestation through delimitation efforts, and we found those also in Lake Sonoma, in Sonoma and Sacramento counties. 2023, we see the kind of the expansion of the infestation. Again, not really that this is natural or flight spread. This is more of a combination of us actually catching up to the infestation and where it was located through natural dispersal, but also through long-range movement and infested material, right? So human activity is a serious contribution to the rapid rate of spread of this particular species, which is also very true of many of our most aggressive invasive insects and pests. By 2024, we see new detections in Mendocino County, the Sacramento area infestation, which started kind of in a small neighborhood, is widespread throughout Sacramento County and Yolo County. We also not included on this map, but we've detected it in El Dorado and Solano counties as well. Also in 2022, there was a new infestation confirmed in Oregon. The genetics suggest it was a completely separate point of introduction, so it's different gene line. And in Oregon, it's primarily in the Portland area, it's primarily a pest of Oregon white oak. And they're very aggressively responding to this insect because at the same time they're dealing with a very aggressive infestation of emerald ash borer. So, boy, that's kind of our future. And so it's a little stressful thinking about that. What else do I have to say? No, we're good. Oh, multiple points of introduction. Just anecdotally, everywhere we see the infestation occurs in wine country. So the area where the infestation started in Oregon, as well in California, is associated with the wine industry. And so what we think is happening is that the insect was introduced on French oak used for making wine barrels. Shh, it happens with all of them. Identification. So I know you guys are into plants and weird stuff like that, so I won't go too deep into ID of insects. But these are them. The female's the larger of the species. That's pretty typical of the insect world. They're clearly the most important part of the whole biological dynamic of insects, and this is no exception. The males are lazy. They don't do much. The female-to-male ratio is 20 to 30 females for every male. The males just don't even really leave the tree. They're smaller. The females are very typically 3 millimeters. So 3 millimeters, right? We're talking these things are tiny. Multiple generations a year, multiple generations in a tree. They have peaks of emergence depending on the temperatures and the season, but for the most part, they just kind of emerge whenever it's really warm out. And by really warm, I say over 70 degrees, and they're kind of flying. So it can happen year-round. So it makes it really, from a management perspective, we're thinking about how do we control an insect like this. It's a big challenge. This is a sweet clicker. Don't worry too much about these slides other than remembering the names for the pop quiz during Q&A, but the point is that just because you see a little brown beetle coming out of an oak tree, a white oak, doesn't mean that it's mob, right? There are hundreds, not thousands, of insects that feed on oaks, hundreds of wood-boring insects, bark beetles. And so the point is that, this is one of the reasons why they're so hard to detect is because there's tons of other stuff occupying the space, and so we're really trying to find this really unique pest. So that's why sometimes these things go undetected, or why we're still struggling to kind of determine if it is a mob-infested tree, if we do see decline, or if it's not something other or a predisposing stressor already kind of native and naturalized or endemic. But we will do a little bit of ID because it's actually pretty easy. So this is mob's butt. I'll keep it simple. In entomological terms, it's the declivity of the pronotum. But basically, you're looking at a big blow-up of a tiny little beetle's butt. You'll notice that, first of all, they're very shiny. They are very kind of parallel on their sides. And I think common with ambrosia beetles and other small bark beetle species is their declivity, or the kind of the rounding of their elytra on their butt. This one is very kind of flattened, very angular. But the most important part of this picture is the tubercles, which I like to call butt spines. My colleagues get annoyed when they say that, but that's really what they are. The arrows are pointing to these little projections coming out of the elytra, which is the outer wing covers that protect the inner wings. We can very conclusively identify ambrosia beetles and a lot of small bark beetles based on the pattern of their butt spines. And so in the case of mob, it has two sets of very large projections, these tubercles coming off of the kind of near the cleft, or you see this is the split in the elytra. So these two sets of tubercles are very large. You can see them with good vision with the naked eye or under low magnification. So if you're seeing little brown beetles coming out of trees and you're concerned they're mob because they're about 3 millimeters, you look for this, and that's a guaranteed identification. None of our native or naturalized invasive similar Xyloborus or other species have that kind of pattern. So there you go. Bet you didn't think you were going to see a zoom up of an insect butt today, but there you try to introduce something new every day. So there you go. And then it's pretty obvious. Here's a site, but you can see they're pretty pronounced projections, so it's pretty helpful. There's other weird things that I won't talk about, like the pattern of these little punctuals, these called striatia. But the point is that we've looked at enough specimens at this point that we conclusively, and through genetics, know exactly what individuals or this beetles are tied to this. Let me get that straight. The morphology is tied to this species. So how do we determine signs of infestation? What's great about mob is that early signs of infestation, actually every point of the infestation, unless you capture adult beetles, looks exactly like every other problem that we have with trees. What might be particularly unique for mob is ambrosia beetles are very small. They typically feed in smaller material. And most of the time that means they're in the upper canopy. And so mobs know, stranger to this behavior, most of the time infestation starts in the upper canopy. What's really interesting, and we're still trying to tease out if this is a true pattern or not, is it does usually start in one branch and work its way down to like the major node at the branching point. We're starting to see maybe if there's a pattern that it starts on the more stressed side. Maybe it's always on the south side first where it's hitting more water-stressed material. But the point is it usually starts in one upper branch. The rest of the canopy, I know this is really hard to see, but you can see this is a dead part of that canopy. This is a healthy part, and then this is a fading part. So you see it worked its way, it started up top, worked its way down, then it worked up in here, and now it's working its way down. So that's a unique thing about mob, a fairly unique thing, is it starts in the upper canopy, but also disperses and spreads and starts to infest the main bowl. So once the tree looks like this, where it's pretty much 99% canopy is dead, then we start seeing boring dust. So here you can see all this like fine brown powder caught in spider webs and in the moss and lichens. That's boring dust from the beetles entering through the bark of the main stem. Sometimes we get introduction of bacterial wetwood or other things that cause oozing and pitching at those locations as well. But this is a clear indication of mob that is kind of unique. And just to be clear again, right, there's a lot of things that attack oak trees and have different types of entrance and exit holes. So if you're looking at trees, we're really looking for tiny little round holes. Remember, 3 millimeter beetle, 0.5, 0.7 lead. And so there's other insects that will be feeding in this place as well. And so we want to make sure that we're really keying in on what is the cause of mechanism of injury. And then this is where you really do, once you get to this point, you can really do a more accurate determination of the kind of beetle infesting the tree, right? You start with canopy decline. That's a pretty standard sign of stress. Boring dust on the stem could be a lot of things. Maybe the texture and the color of the boring dust suggests things, right? Ambrosia beetles feed into the sapwood, so they're going into the wood because they're farming a fungi, whereas true bark beetles are feeding kind of in the cambium, the inner phloem, outer xylem, where they're eating that nutrient-rich tissue. But when you see galleries going into the wood, so like this is the main stem we packed away, you can see all the kind of the black holes, the buckshot appearance. These are all galleries from Mediterranean oak borer. And then this is kind of a cross-section. It's a very unique, don't worry about, it's not too important for the purpose of this talk, but the pattern of the feeding is actually very unique as well. Most ambrosia beetles are very territorial and will avoid feeding into each other's galleries, but mob feeds on the same plane and they'll crisscross and kind of feed into each other. So that's also unique. And then, like I said, other things get introduced. So here we see some kind of staining in the sapwood associated with these galleries. So obviously there's multiple kind of issues occurring at one time in these trees. So what are we doing for management, right? We're still only a couple of years into studying and understanding this particular insect. The big push right now, and when I say big push, it's myself and a colleague from Cal Fire, Curtis Ewing. We are kind of the research team for mob. Once CDFA, the California Department of Food and Ag, rated mob as a bee pest, it lost a lot of the financial momentum that we initially had. But so the big effort right now is delimitation, really trying to figure out the extent of the infestation, and then if we can develop some remote sensing models for early detection. We still aren't entirely sure if this is an insect that can attack healthy trees. How do we determine a tree is healthy? That's a good question. A lot of the valley oak that we're looking at are the urban forests and the urban spaces where they're all stressed for some reason, some silly thing that we've done to them. And so it's really hard to know if mobs establishing in trees that are otherwise relatively healthy or they already have some kind of underlying stress that's making them more vulnerable to infestation, which would be more similar to kind of how native insects would behave. But they are killing trees rapidly and very aggressively, even if that's true. And unfortunately, in California, we're always in a state of drought, so these trees aren't in great shape. So from a management perspective, we're still kind of suggesting that the best thing we do is improve vigor, right? So keeping your trees, reducing stress through supplemental watering in the shoulder seasons, extending the rainy season, mulching, things like that to kind of help maintain the health of those trees. The big one is not to move infested material. That's a big challenge with having to deal with post-fire management and deal with right-of-way and utility management, but we have to kind of think about how moving firewood in particular, but how we move large amounts of this material, it spreads infestations pretty rapidly. And then we do know effectively the best way to deal with it is to destroy the material. So chipping it, burning it, we know we can control the infestation very easily that way. If we're to be aggressive enough about it. Solarization, which is a common practice, not so well for this insect. They're so small that even little tiny tears or, if there's plastic or even thin metal pulled tight against the bark of an infested tree, a beetle will just burrow right through it. So trapping is very difficult. It doesn't kill the insects. It just heats up that space and they emerge faster than they would in the ambient temperature. So it doesn't actually control the infestation. Chemicals, don't know yet. We're still studying it. Have a way to go. Other pests that I get a lot of questions about, and I'm probably hopefully you're familiar with, so I'm not going to spend too much time. But Western oak bark beetle, see this one a lot. People get, because it's a tiny little insect, lots of entrance and exit holes. We see a lot of concern around that. This is a native insect, true bark beetle. So, maybe similar kinds of infestation symptoms, but not necessarily the same issue, right? It's a native insect responding to heavy stress. Oak branch, so diplodias and cryptocline or discula, these are also things that cause flagging in the canopy that can be confused, and I get a lot of questions about this for being mob, but they're just kind of native pests that cause issues during stress or warm, wet springs. And then last, the most important one is the invasive shot-hole borer. Who's heard of that one? Okay, all right, good. So you guys are paying a little bit of attention to the insects. If y'all are aware, for the longest time, this was really an issue in Southern California. Just last year, the end of last year, we detected it in San Jose, and also in Santa Cruz. And in Santa Cruz, the Santa Cruz insect actually ends up being a new species of Euolacea interjectus. So that's fun. We have now, because invasive shot-hole borers, there's 2 species, now we have 3, so we'll see how that goes. But it's like a cousin of mob, so very similar symptoms, kind of causes the same kind of, even shot-hole effect of boring on the tree. Different insect, also attacks oaks. So big concern, too, especially when these 2 ranges overlap. All right. Resources, a field guide to insect disease of California, amazing resource. It's 20 years old. We're working on updating it. The CODA, if you've never checked that out from the same authors, is a great resource we're working on updating. And then we have 2 websites, one for MOB and one for iShab in UC. And then UC Oaks is also a great place to get information about pests and diseases. And with that, is any questions? Thank you. And also, I want to thank my colleague Curtis Ewing, who's a huge part of this project and doing a lot of field work himself. So thanks. You know everything that I know? Okay.
Hi, cool talk. I'm curious if there's an interaction between the mob and its associated pathogens and climate, like whether rainfall or any climate variables can affect where the infestations occur. Thank you.
Yeah, that's a great question. I have no idea. You do see that, right? Sometimes there are, the insect, through climate change and range shifts, you'll see the insect range will shift, but its symbiotic fungi won't, so it'll pick up a new host. Or maybe with an introduced insect, it picks up in its journeys an invasive symbiotic fungi, a virulent or pathogenic symbiotic fungi that introduces here as well, or it picks up a already native fungi that then becomes a virulent pathogen of a tree. So we see all kinds of complicated interrelationships. We have not been studying mob long enough to know. Good question, though. It has across the entire latitudinal, is that the right one? What's elevational gradient of veil oak? We've seen it in those trees. So far, the limited range we have hasn't shown that.
Thank you. That's super interesting.
I have time for one question. And then there's a pop quiz.
Great. So I have a question. Do you only see these in true oaks, or have you found them in tan oak at all?
No. So they're only in the white oaks, only in Quercus, in white oaks. In their native range, they have a much wider range of hardwoods, so cherries, walnut, a lot of other species, but so far they've only been in oaks.
Great, thank you.
All right, thanks, y'all.